This is LING 270, Language, Technology, and Society, Module 3, Decipherment. In this lesson, we'll talk about how decipherment works. So what I usually do in class is I will solve a cryptogram puzzle along with the class. So if you haven't heard of a cryptogram before, what it is it's a kind of puzzle where you take a sentence in English and you replace each letter with some other letter in the Latin alphabet in a way that kind of scrambles up the meaning of the passage. And to solve the puzzle, what you have to do is make educated guesses as to what each letter might represent until you can end up solving the whole puzzle. And what you'll kind of notice, especially at the end of this module, is that this process of solving a cryptogram, the assumptions and educated guesses that we'll use to solve this kind of puzzle is actually very similar to the processes used to make a decipherment. So that's why I like doing this kind of demo. So what I'm going to do is I'm going to go to this website here and do a demo decipherment, if you will. And while I'm doing that, I'd like you guys to try to keep some things in mind. So, so pay attention to what kind of educated guesses I'm making while I'm trying to solve this puzzle here. And also pay attention to the speed of the decipherment. Notice how the speed of decipherment changes as I get later in the puzzle. So yeah, I'm going to go do the demo now, and you can go to this website too yourself if you're interested in trying this out. And hopefully it goes well. It might take a long time, but we'll see. All right, so I'll switch screens now to a cryptogram. So here's what a cryptogram looks like. You can see that all the letters have kind of been scrambled, so you don't really know what it's actually saying, but we can see that it's a quote from Charles Dickens. So it's very difficult to actually get started with a decipherment like this. But there are some words that we can start out with that might be a lot easier to guess. So first of all, we can see that there's one word here which is which is a one-letter word that was replaced with the letter M. So, well, in English, we know that there are a very small number of words which actually are like this. There's I and A. So it's a good chance that it's one of these two. So I'll make a guess that this word is I to start with. And you can see in this website that once you make a guess like this, it'll fill in all the rest of the slots with M as well for you. So yeah, that's an initial guess we can make. So we can see here now that there's a word that is ZMAA. So now think of a word in English which ends in the same two letters, and the second letter is an I. I think that might be an S, but it could also be an L. It's kind of hard to know right now. So this word could be miss, for example, or it could be will. So let me try will and see if that kind of makes anything fall into place. Doesn't really look like it at this point, but so. Another thing that I might want to try is a word like this. So I see that the letter U is pretty common here, and it looks like it likes to be at the beginning and the end of words. I think it might be possible that this word might be the word else. So else is a pretty common word. Another possible guess could be that. So so those are very common four-letter words which begin and end with the same letter. Yes. Okay. So it looks like a lot more things have kind of fallen into place here. And we can see that this word, if by making those guesses, then this word is the word is. So by making guesses as to what some of these words might be, it looks like some other words kind of start to match as well. So I think that's a good sign that we're on the right track here. Yeah, so let's see where we can go from here. So here's a 3-letter word, E blank. I think a really common word in English that might put this here would be the word ever. So let's make that guess here. And here now we can see that it actually a lot more kind of letters filled in, and it's as you might be able to see, the meaning is starting to become more and more apparent. So for this, based on the guesses that we've made so far, this word is probably the word service. There's only one letter missing now, so I'll make that guess. Yeah. So now where do we go from here? Okay, so here's a 3-letter word. It's I blank, but it's not is because we already have a symbol for S. So it could be the word if, or it could also be the word in. And I'm seeing in the blanks where this V is occurring, I'm seeing that this letter is very, very common. And I know that N is a very frequent letter of English. So I'll make that guess here. Okay, so, right, so that looks like it's, that filled in quite a lot of words here. So here's a 10-letter word that begins with ever and ends in. So I think this word is probably everything. So I'll make that guess here. And that filled in a lot more words as well. And look at, yeah, now all of a sudden we have all these words kind of coming in. So this word, that's pretty clearly nothing. That word, so here, let's look at this, these words up here. We see boys, girls. So based on the sentence context, I think this word is pretty clearly boys. It wouldn't be toys, for example. That wouldn't really make sense, but boys and girls is probably a likely answer here. So this is probably and this is the word but. Yeah, so now look how quickly all the words and letters are kind of falling into place. So now what letter might this be? So it can't be, this word can't be that, but it is probably what in this case. So now what I want is, so I would probably say that would be facts. And we can see if that's facts, then that word down here will be life. So yeah, now what I want is facts. Teach these boys and girls nothing but facts. Facts alone are wanted in life. Something, nothing else. I'm gonna guess that's plant, nothing else. And then that word down here would be upon, so that makes a lot of sense. Plant nothing else and root out everything else. You can only form the minds, I think. That would be form the minds of reason. Oh, there we go, we just solved it. Form the minds of reasoning animals upon facts. Nothing else will be of any service to them. So hopefully you noticed that it took me a really long time to get started with the decipherment, and I had a really hard time. But then once I made a good initial guess, a lot of other pieces started falling into place, and I was able to make the decipherment go much faster and faster. And you'll notice that this is the way that a lot of decipherments actually took place. Once you start making good guesses, then other pieces of information start to fall into place. And yeah, the decipherment tends to accelerate. And what you probably also notice is that I made guesses based on lexical frequency. So I looked for the words which occurred most often, and I made guesses based on which kind of letters occur often, and that kind of thing helped me out quite a bit. And also when I was doing the phrase boys and girls here, I used the kind of sentence context to find out, oh, what word would be good in this position. So using these kinds of properties of the English language, it can help me solve this kind of puzzle, even though I don't know how each letter has been replaced with any other letter. And yeah, basically the process of decipherment is basically the same kind of thing, except each letter, it represents a completely unknown symbol rather than a different letter of the English language. So, so definitely try out Cryptogram for yourself and try to notice how the process of solving a cryptogram kind of unfolds. All right, so I'll go back to the slideshow here. Give me 1 second. So yeah, so yeah, let's review what kind of information helped us solve this cryptogram. One factor was word frequency, words like the, I, else. By looking at which symbols tend to occur more frequently than others and which patterns of symbol tend to occur more frequently than others, we can match those up with the frequencies that we know about in the English language. Similarly with letter frequency, you can see that I made some of those assumptions as well. And also another helpful thing is which letters can go next to other letters. So we know that some letter combinations, maybe, I don't know, TX in English, that is something that's probably pretty rare, but something like TH would be something that's very common. And we can make assumptions like that as well. We can make assumptions about which words go next to other words, boys and girls, for example. That's another thing we can think about. And which words make sense in the context, and maybe even if the author's identity might help. In our case, in the example I just did, Charles Dickens probably didn't really help out that much, yeah, a lot of times who the author is can help you figure out what kinds of words that author might have used. And notice with the speed of the decipherment that it started really slowly, but once things started falling into place, things started to speed up very quickly. This kind of thing happens in real decipherments, and it's a good indication that you're on the right track if you start to see this speed up. If you make the wrong initial guess, you don't really get this kind of speed up as well. So when we talk about decipherment, we can say that it relies heavily on the process of the scientific method. So we can't know with 100% certainty what an ancient script really represents. Like, we can't go back in time and ask a person how the writing system actually works. The only thing we can really do is make educated guesses. In other words, in the language of the scientific method, we can only make hypotheses about what the writing system is. And the only way we can determine how good our hypotheses are with independent verification. Or in other words, through experimentation. So that means we get an idea of what how this decipherment might work, and then we have to apply that to some document to see if that really works, if that really holds water. And if not, then we have to reject our hypothesis and make a new hypothesis, as this diagram kind of shows. So yeah, if our first hypothesis is bad, then we can improve it, and on until we end up getting the best hypothesis that we can that explains the data. So in the next few lessons, we'll look at some real examples of decipherments to see how this kind of scientific method unfolded. And you'll notice that the process has a lot of commonalities with the way that we solve a cryptogram. So I'd like you to keep these in mind as we go into the next couple of lessons.